lung cancer tumors over PDX or PDX-A TIGIT combination therapy. And this is being delivered by Jeremy Ratiu from Gaithersburg in the USA. Thank you.
Thank you. Hi, my name is Jeremy Ratiu. Before I begin, I would like to thank the organizers for giving me the opportunity to present our exciting preclinical findings from the study of relvegostomig in freshly resected non-small cell lung cancer tumor explants. Today I'll show you that relvegostomig exhibits a unique mechanism of action through its bispecific design, and that Fc functionality may impair anti-TIGIT mediated immune activation. Here are our disclosures. Relvegostomig is a monovalent bispecific antibody specifically designed to support the synchronized and coordinated inhibition of PD-1 and TIGIT. It was engineered with a triple mutation in the Fc domain to prevent macrophage and NK cell mediated depletion of PD-1 or TIGIT expressing effector cells. Relvegostomig has demonstrated promising anti-tumor activity with a favorable safety profile in the ongoing phase 1, phase 2, Artemide-01 trial. Among patients with high PD-L1 expression, it has achieved a confirmed ORR of nearly 62%. Among patients with low PD-L1 expression, that's TPS scores of 1 to 49%, relvegostomig has exhibited a confirmed ORR of 29%. In the past, drug development has largely focused on utilizing animal models, but these often fail to translate to human. What we and others have found is that patient-derived ex vivo tumor models can more faithfully predict the drug efficacy observed in patients. Voibel et al. Showed that these tumor explant models predicted with high confidence clinical outcome. Building on this, we also established our own models, which similarly showed a high concordance between ex vivo response and clinical outcome in patients that went on to receive checkpoint blockade following resection. Regarding our methodology, upon receipt of each tumor, a portion is collected for baseline assessments, and the remaining tissue is processed for drug treatment. Each treatment is evaluated in 8 to 16 replicates, and after 96 hours, interferon gamma levels are quantified as a surrogate of ex vivo immune activity. The frequency of tumors exhibiting statistically significant changes in interferon gamma is defined relative to their untreated controls. In this study, we set out to evaluate the ex vivo activity of relvegostomig in freshly resected non-small cell lung cancer. Specifically, we compared relvegostomig's activity against clinically approved PDX and sought to determine the importance of its bispecific format by comparing it to its parental anti-PD-1 and anti-TIGIT antibodies. Finally, we aimed to determine the importance of Fc biology in anti-TIGIT therapy by comparing Fc-reduced relvegostomig with Fc-active co-administrations mimicking other clinically evaluated approaches. So first, we compared relvegostomig activity to that of pembrolizumab in a cohort of 81 freshly resected non-small cell lung cancer tumors. To orient you to this heat map, each column represents a unique patient tumor. Red coloring indicates statistically significant ex vivo activity, while white indicates a lack of increased activity compared to our untreated controls. Through these studies, we have found that relvegostomig elicits broader and deeper immune responses than pembrolizumab, as evidenced by a 48% increase in the proportion of tumors responding to relvegostomig, and 65% of tumors with overlapping activity showing greater interferon gamma induction with relvegostomig treatment versus pembrolizumab. Additionally, we found that relvegostomig exhibited increased ex vivo activity compared to pembrolizumab across all PD-L1 expression levels. While the tumors in this study were not sourced from relvegostomig clinical trials, the ex vivo activity we see is consistent with clinical effects observed in Artemide, again suggesting the suitability of this assay in predicting responses in patients. So we were interested to understand the potential biomarkers of relvegostomig response. As shown in the left panel, PD-L1 expression correlates with increased ex vivo activity for both pembrolizumab and relvegostomig. Building on this, we sought to determine if TIGIT's ligand, PVR, could serve as a potential biomarker of relvegostomig activity. In the middle panel, you will see increased response to relvegostomig as a function of PVR expression. However, we also noted a significant number of non-responsive tumors exhibiting highly variable PVR expression levels. This suggests that PD-L1 remains a more reliable and consistent biomarker for predicting ex vivo responsiveness. We next sought to determine the individual contributions of relvegostomig's PD-1 and TIGIT binding arms to its overall activity, as well as the importance of its bispecific format. We observed that, that the parental anti-PD-1 performed similarly to pembrolizumab. In contrast, the parental anti-TIGIT alone was insufficient to induce robust T-cell activation. Co-administration of the parental anti-PD-1 along with the parental anti-TIGIT led to a modest increase in ex vivo activity over anti-PD-1 alone. Importantly, relvegostomig consistently exhibited the greatest frequency of ex vivo activity across our study. These ex vivo findings are consistent with our previously disclosed in vivo work, which demonstrated that relvegostomig elicits a greater anti-tumor response compared to PD-1 alone or in combination with anti-TIGIT in humanized mouse models of lung adenocarcinoma. Collectively, these data suggest that the coordinated bispecific inhibition of PD-1 and TIGIT can promote greater ex vivo activity in patient tumors than the individual components or their co-administration. Today, clinical development of anti-TIGIT immuno-oncology agents has largely focused on utilizing Fc-active anti-TIGIT molecules. Our results in murine models suggest that Fc functionality provides a benefit to anti-TIGIT therapy in mice. However, we wanted to understand if these results translate into human tumors. Compared to pembrolizumab alone, co-administration with an Fc-active anti-TIGIT, here identified as FCA, actually led to a decrease in the frequency of tumors exhibiting ex vivo activity. And the addition of an Fc-reduced anti-TIGIT actually led to a slight increase in the frequency of tumors exhibiting activity. Importantly, relvegostomig elicited even greater activity than these co-administrations, further demonstrating the importance of its bispecific format. And these data, we feel, are a good example of why we believe the ex vivo model gives a better representation of human biology than other preclinical models previously. Based on these findings with co-administrations, we next sought to determine how Fc functionality may modulate relvegostomig activity. To address this question, we engineered relvegostomig on different Fc backbones. For these studies, we compared the activity of our standard Fc-reduced relvegostomig to Fc-active or afucosylated versions. Afucosylated antibodies are known to promote enhanced Fc receptor engagement. Consistent with our findings for anti-PD-1 and anti-TIGIT co-administrations, we observed an Fc functionality-dependent reduction in ex vivo activity. It is well established that Fc-active antibodies can promote antibody-dependent cellular cytotoxicity, or ADCC, through engagement with Fc gamma receptor 3A. We tested the ADCC capacity of these three relvegostomig formats and determined that Fc-reduced relvegostomig does not induce ADCC, while the Fc-active and afucosylated versions induced modest or substantial ADCC in vitro. Looking at the correlation between Fc gamma receptor 3A affinity and ex vivo activity, we observed a strong inverse correlation. Greater Fc gamma receptor 3A binding affinity for these antibodies correlated with reduced rates of ex vivo activity. Collectively, our results demonstrate that Fc-reduced relvegostomig is differentiated from its Fc functionalized counterparts and suggests that increased Fc functionality in anti-TIGIT IO agents may be detrimental to the overall anti-tumor immune response in human tumors. In summary, relvegostomig is an Fc-reduced monovalent bispecific antibody enabling the synchronized, localized, and coordinated inhibition of PD-1 and TIGIT. Our preclinical ex vivo data suggests that dual blockade by this bispecific increases immune activation compared to anti-PD-1 or anti-TIGIT monotherapies, and the bispecific mechanism of action promotes greater T-cell activation than anti-PD-1 TIGIT co-administrations. Finally, Fc-reduced anti-TIGIT antibodies may elicit greater anti-tumor activity than an Fc-active format. Rilvegostomig is currently being tested in multiple phase 3 trials in non-small cell lung cancer. They are listed below. I'd like to thank everyone who contributed to this study, as well as, in particular, the patients whose resected tumors were utilized and the investigators who contributed to their collection. Thank you.